Hi, everybody. My name is Stefany. I am the creator and designer of the C256 Foenix. Welcome to this presentation. Um, Before we begin, I would like to give some thanks to Jeffrey from VCF East for inviting me. I mean, I'm talking to Jeffrey on a regular basis, but I would, you know, um, give those thanks to everybody that was involved for inviting me. It's an honor to be here today to present you this retro computer and its inner working. And I hope you'll find it interesting. Thank you for being there and spending the time to watch this. I hope you'll like I said, you'll enjoy it and you'll find it interesting, and hopefully you'll join in for the future of this endeavor, because I certainly need more people to get involved to make this more success and to keep this going. Um, yeah, so I would say that early on, the in at the beginning of the year, in April, I was supposed to give like a full class on the C65, 65, 816. I'm going to chuck it down a little bit and put a little bit more stuff around. Um, but I still want to talk about my experiences dealing with the 65C816. I think that was quite interesting. And considering that the day's theme was supposed to be about the 6502, I think that is very suitable. Um, so at this point, I guess I should present my agenda. So today, well, sorry, it's slides, but I'll try to make it a little bit more interesting. So I want to talk about what is the Phoenix. We'll spend about 15 minutes on this. What is it? Where is it now? What happened? I'll do a couple of demonstration to show you on the machine a couple of demos that Daniel created. Talk about Daniel later. Then we'll go in the heart of the presentation, which is really about the processor. What are those challenges? What I had to face? My hubris. I think we're going to talk a lot about my hubris, and because I'm a hardware design engineer by trade, I've designed like a countless amount of products. Did some schematic PCB debugging. The whole 9 yards, FPGA design, mechanical design, the whole thing. So when I got it started in this, I was pretty well equipped. But sometimes, a processor 14 megahertz, what could possibly go wrong, right? So at this point, I want to end the whole presentation with good news and new stuff and exciting stuff. And again, I hope that you'll be joining in the future for the future of this project, because I think it's really exciting, despite the fact that at some point I kind of decided to stop, but we'll talk about this later. We'll keep the drama for later. All right, so I don't want to spend too much time on this. So ultimately, how this computer started, the development of this computer started, I've been telling this story so many times. It's about David Murray, the 8-bit guy on YouTube. The Gigatron episode in April 2018. He talks about his dream computers at the end. He laid down a list of stuff he wanted and figured that, hey, maybe some people out there will do it. And I guess a couple of people did, and I was amongst those people. So it took me a while. It took like a few weeks to think about it and say, okay, how I would do this. I was definitely in the retro mood and getting I was about to get myself a C64, and I said, you know what, this is interesting. Let's do this. And basically, how I went about it was, David laid it out, and I was going to play it out, but I was going to spin it my way, because I realized that, okay, I'm going to spend a lot of money on this, have my own vision of what he wants, so I will spin it that specific way, which was probably not David's way, but anyway. It's like any writers, screenwriters getting their stuff being produced, right? The director spin it their own way, So it's the same thing. My so the vision, I at this point I could say, what was the original vision, what I wanted to do. I'm coming from a place where I've designed a lot of different products. I want to honor, to a certain degree, Commodore's legacy without designing anything Commodore, because I didn't want to cut with, copyright infringement, stuff like this. So I'm going with, I take David's idea, said, okay, let's create something that could have happened. Something like a different timeline where, Jack Tramiel doesn't get kicked out of his own company, go and Atari and Commodore buying Amiga. Let's say that none of these things happen. And let's say they decide to, okay, we need to get on the 16-bit bandwagon. Let's design something. And I think it's very unlikely that Commodore would have let go of the C64 compatibility, because they were going to with the C65. So they were really, really, really hanging on to this. But I'm taking a different path where they would, because Amiga was really this next generation where nothing was compatible. So they did, in a way, sever this tie with the C64 by buying Amiga. So I am heavily influenced by Amiga at this point. So I decide to go and say, oh, I want to use FPGAs, even if David is not so much for them. For me, FPGAs represent the ASIC development of Commodore, which was paramount to their success. Without these custom chips, without Jack buying, the ASIC division, things would have never happened that way. So I'm taking a part of this and saying, bringing it back here and saying those FPGAs will be considered as ASIC. And it's the reason why there was no reason for me to share I don't want to share the FPGA content, because allowing people to modify the FPGA as will would be counterproductive to the idea of these things need to be fixed in time to support every software programmer, so they always have the FPGA to be the same. I decide to go along with the 65816. This is a good choice. It's the right speed, not too fast, not too slow. Even at that point, it's very comparable to a 68000 at 7 megahertz. I have access to 24-bit range. This is great. I can do, like, my graphic implementation makes sense. So I go with this. And finally, I decide, okay, it needs to have a lot of graphics and sound. Very important to me. Because at the end of the day, you can have like a lot of people use like a small 8-bit processor these days, and it's great. They put some memory, they put some flash, they put like a CIA, and then they have a serial port, and everything is good and dandy. But the problem is that it's kind of limiting, and I think it's without sound, without music and graphics, it makes the experience less interesting. I think having access to these things motivate people to go do more, because it's more stimulating, of course. I mean, the sound, seeing a sprite appears, moving a sprite around is very, involving. It really gets you to go the next step. Otherwise, just, there's just so much you can do with text, right? So anyway, so that meant also that I had to design my own custom chips, which was part of the challenge, I guess. So I go on and I start. So this is the rundown of what happened. By the way, I have a Cintiq tablet here, so that's why I'm kind of shaving. I'm touching my tablet. Maybe you don't see me, but anyway. So that's why I'm looking down. The whole thing starts in April 2018. I take some time to think about it. At this point, I'm kind of, okay, I'm going to do this on the ground. I'm not going to bother myself with the whole politics and everything. But along the way, I start collecting all the parts. I use SnapEDA to get my parts. Great company, great stuff, by the way. Shout out to them. But as an happenstance, I end up being the 100,000 subscribers. Natasha, the CEO, decided to make an interview with me, and then the word gets out. And then I get a lot of attention, which influenced a lot the deployment of the first platform, which was a amalgamate of what I wanted and what people wanted, which was weird, because people were thinking, oh, that's another C64, or it's going to be compatible with C64, like a more advanced C128. And I didn't want to do anything with C64. Playing, Choplifter or playing like Blue Max is great, but there's plenty of possibilities for people to play Blue Max on the C64 these days. So I didn't want to go there. I didn't want to get myself into making a perfect replica of a 6567 that a lot of people did already. I didn't want to revisit. I wanted it to be its own thing. I believe in the idea that I wanted to create a new platform for people to rekindle with the idea of discovering a new machine, learning this new machine, developing new stuff for this machine. That was the goal. That's still my goal to this day. Create a new library of games for a new machine. But obviously, that machine needs to be successful in terms of, but they're interlinked between each other. Software, support, machine, availability, and price and everything. I'll come to that later. Anyway, so in October, I go to the Fall Retro Expo. I meet with David. It's great. We sit down. We talk about it. We have similarities in our ideas. We have divergence in our ideas. I talked to a friend Yuri that I met at CRX a few months before. He gets me straight and said, you know what, this is great, but it's not really what you want to do. And I come back later, a few months later, with the B2 version, which means I spend this thing a couple of times to arrive to this version. And it starts to look like what I want. Out of this, I meet great people, Peter, Daniel, and Mike, and Adrien, which are great, help me achieve a lot. And they're still here to this day, and they're doing awesome. This is in spring 2019, and then I go down the rabbit hole. This is really my hero's journey, and I'm going into the underworld, where I start creating these different versions, and they all have issues. I bring in these new chipset, like these new sound chips, and it's really a nightmare for me because I feel the pressure because I already start selling it, the promising to have like a C version, and I'm promising Steve putting more pressure on me, which just leads to almost like a depression. And then finally, I emerge out of my underworld in fall 2019. It's kind of surprising considering the fall is supposed to be going in the underworld. And anyway, I'm getting out of it. And then finally, the C4A in January starts to be shipped. By April 2020, I think everything is shipped. And then I start selling the C4B. But at that point, I didn't implement the whole new version of VK I wanted to have. It's not finished. And I say, hey, I want to ship those boards only when I'm finished, which is the case, should be the case by the time you see that. So this is where we stand. So quickly, this is the overall block diagram. So the whole process got me to today to this configuration, which is you have an FPGA, which is a Cyclone 3 to drive like four chips to get 32-bit wide memory bus, because I'm limited to 100 megahertz speed with the RAM. So I need to get more bandwidth to do a lot more, to do bitmap tile layers and sprites and all these things together. I need to have more bandwidth, so I expand my bandwidth by having more chips, but more bits per chips. That's what video cards do these days anyway. I put a little bit more extra memory, so 4 megs. I integrate 2 chips that I used to have, which was Beatrix and Gavin together. I create Gabe, which end up being the system chip, plus math blocks to do float and fix to help the 65816. And I include all these beautiful unused Yamaha chips because they're complex to be dealt with and most people don't use them, which is kind of ironic. OPL3 was my choice, and I stuck with it, but then I had up the other guys. And then from the very get-go, I wanted to have the Super IO, I wanted to have the floppy, the MIDI ports, and so on and so forth. Because I saw the Foenix early on as a very, like a music box, like somebody wants to do chiptune, that would be the box to use it for. It's a high-end machine. It's meant to be used for development also. At this point, I want to talk a little bit about the VK2 chips just to give a glance. So it supports multiple video resolution. It did the pixel. It has lookup tables that you have 24 bits per byte, so you can have all the colors you want, but you're limited in the number of colors you can see at the same time. 1024, 202K colors at the same time if you use all the lookup tables. You have 2 layers of bitmap, 4 layers of tiles that you can scroll, 64 sprites. Sorry. You have an SDMA block that does DMA for the internal memory, and then you have the VDMA, which does the DMA for the video memory. And when you want to transfer stuff, they talk to each other. You could literally run both at the same time. So at this point, finally, this is in a nutshell how the graphic chips deals with. So layers, you can have sprites in between all those different layers. You have the layer for the tiles, you have the layers for the bitmaps. So yeah, it's pretty comprehensive. It's yeah, a lot of work in there. And like I said, support different resolution. It's pretty complete. At this point, Gabe has interface to all these magnificent chips. Like I said, these guys are a pain in the butt to get because there's a lot of them that, China has been going on this rampage about stripping off all these chips out of all those boards, wasted boards. But some of them don't work and they still sell them. They re-laser them. It's very difficult to find working chips. You get chips, they're not real sound chips. They've been re-lasered like they were chips. They're not sound chips. There's something else. It's crazy. So funny enough, the PSG is amongst the chips that are real, and probably somebody has stock still somewhere. There's also inside the unit the SID. It's the Gideon version. Thank you very much, Gideon, for letting me use this core. It needs to be fine-tuned, but it's there. So, like I said, a lot of graphics, a lot of sound. That was the point. And this is what it is today. So if you're getting an FMX, this is literally what you get. And this is on top of having the SD card, expansion bus, like I said, the MIDI. So much potential here. And the price is still pretty reasonable. $320 I think, is fairly cheap. So at this point, I'm going to break the rhythm a little bit. I want to show you what it's like to download something. So I'm going to bring something on the screen here to show you. So this is the Foenix IDE, which is a software that allows you to do some developing as an emulator. You can run your code in there. It supports the graphic chips and all these things. The sound is not there, but most of everything else is there. So you certainly can do a lot of development there. And an interesting part of it is that you have the ability to download your code straight in the machine through the background debug mode that I call. And I would like to show you. So I would like to show you first the tracker. So I'm going to put the screen. So I'm going to cut the output of the unit. I'm going to unmute the sound. So I'm going to cut that in. So hold on, I'm going to put this next door here. So usually we use a 64 task as a compiler. And then we create an X file with certain things, of course. And then we can load it in the machine. So I have a machine running next to me. I can probably show you here. So there's the keyboard, there's the machine working here. So try to not. So I'm back in the screen. So at this point, what I would do is simply send the data in. So this is the tracker that Daniel Tremblay designed. It targets the OPL3. So what I would do is literally control load, control L, and I'm going to choose a file. I don't see clearly on the screen right now, but I'll take one. This is a RAD player. And then I would start the tune. All right, so this is an example. So sorry. At this point, I'm going to reset the machine, and I'm going to look for the Tetris game. Hopefully it's going to work. So this is another software that Daniel designed. He's been migrating the software from the VK1 to VK2. So I think there's still some issues. So because if I'm trying to move the part, I can't. So probably a bug got introduced. But yeah, otherwise it's supposed to work. So it's a Tetris. And with sound, it's really cool. Daniel did a wonderful job. He's been a hard believer since day one. I'm really grateful to have him on the team. So this is what it is. All right. So I will cut that out. So let's get this out of the screen. I will remove the sound. I will cut it out, and I will remove these little guys, and we can move on. Okay, so we're 20 minutes in. I took a little bit more time. All right, so the CPU. Let's talk about the 65816. Okay, so at this point, the reason I used it is because it was part of David's requirement. Like I said previously, one of the reasons I stuck with it was because it was perfect. It was fitting in the vision. 6502 based, fast. Fast, 24-bit range, and you know, it's perfect. 68,000 would have been like a stretch, and 6502 would have not been enough. So it makes perfect sense. Little did I know that I was going to struggle, and here I talk about my hubris. Been doing design for many years, been dealing with PCI Express, the SDRAMs, no DDR RAMs, like 300 megahertz speed design, and I'm going to design something at 14 megahertz. Yeah, it's slow, right? Yeah. Okay, so I'm going to do a disclaimer here. What I'm about to talk about is my struggle with the part. Doesn't mean that it's difficult to interface with. I think there's a little bit of me. There's a little bit of me pushing the edge, the design and the part, and creating a lot of problem for myself. So it's in no ways Bill's fault at this point. I think it's really about me, but doing what I do, which is really pushing the boundaries of things, and I get myself a lot in trouble. So the first challenge, so I'm going to talk about 3 challenges. The first challenge was the multiplexing. And the multiplexing has its own challenge because one would think that, oh yeah, the CPUs run at 14, and in reality, it does work at 14. But when you talk from a system perspective, it's not quite 14 megahertz. In reality, it's actually 28 megahertz, because the way the 65816 works is that in order to be pin compatible with the 6502, it had to have this capability to use the normal bus as a 6502, 64K, but then being able to expand with the 6816 was to use part of the clock cycle to introduce this extra byte of bank number, if you will. So the bank address is actually supply on the first part of the clock. Okay, so if this Phi2 runs at 14 megahertz, when the clock is low, then the bus address has been supplied. And I totally understand why somebody would have done that this way, because, package limitation, we're back 30 years ago, it makes sense, right? And then the actual transaction with the bus takes place on when the clock cycle is high, going from high to low. Again, would make perfect sense, right? But it does. It's just that it's very limiting in terms for many reasons. First of all, there's a lot of legacy parts, like the flash is a 70 nanoseconds flash. And the clock, normally, if I would have had the whole clock cycle, then I would have been able to access it, get the data out, and it would have been great. But that's not what it's happening here, because I only have 35 nanoseconds to get the data out of the flash. And considering that the clock cycle is only using 35, then the flash doesn't have enough time after the address has been chosen, the chip select has been turned on, to get the data out in time. So I would have to stretch the cycle a second clock. That means that anything I would run from flash from that point would be running at 7 megahertz, because I would have to stretch the cycle one more clock cycle to get enough time. And then it brings its whole bag of shenanigans, which I'm going to talk a bit in my third challenge or second challenge. Well, anyway, so this is something I overlooked. I started doing this thing saying, oh, it's 14 megahertz, the other multiplexing. I didn't think about it at first. When I started implementing it, I realized that, this is cutting down my time. And it's kind of tricky because the window of time where the CPU needs to get its data valid and so on is very short. So it's a slow processor, but the intricacies of getting the data on time is complex. So that was a challenge for me. Because I just put a lot of stuff on the bus, and that's something I will be talking about as well, bus loading, and that was one of my first challenge. So I've tried many ways. So I was the deal is at early on I wanted to use the FPGA to do the demuxing internally, then feed everything. But because of the FPGA nature of not exactly all the lines and everything being the same, it would take a lot of work to make it the same. It was just creating a lot of problems, and I'm fairly good with FPGAs, but when it starts in the timing tuning, I hate it. So I tend to be lazy. So I made my job easier, and by later just introducing the latch outside, because latching in FPGAs is just a pain in the butt. Anyway, that's what I did. Again, my part mostly, but it's tricky. And I was warned about this early on. I didn't listen and say, oh, no, it's going to be fine. 28 megahertz, not that fast, right? Anyway, which brings me to the second challenge. So the challenge number 2 was the extension of the bus. Because one of the things, and that took me another little bit of time to understand, is that at some point, when you're actually extending by bringing there's a line on the CPU, the relay line, that gets the CPU to stop completely, statically to stop and say, okay, you want the bus? Fine, take it. Tri-state everything. Just, okay, use your thing, do your thing. It's all good and dandy. And what happens is that you need to keep this I value valid. So at first I didn't keep that value. So I was getting the latch to latch every cycle of the wait time, which was getting me to have false data, disabling the chip select, and it was a nightmare. And took a while to really make it work properly where, okay, so when the latch is on, when the ready line is on, then the latching needs to stop. Because you want the chip select, the high part to be valid, so the chip select will be working, so I can actually have the data I want. And I was driving, for example, the RTC chips I'm using needs some extension, needs some way more than 35 nanoseconds to actually get the data out. So I need to extend the cycle. The Super IO was super slow. It takes 10 clock cycles to get the data out, considering that I have to go through misstability, flip-flops to, because I'm crossing clock domain. I don't want to go there. That's another kind of worms. So anyway, if you see on the graphics, here's a cycle. You see the chip select gets enabled here. AF is the I part of the address I'm targeting. 800 is where the RTC is. And you have the output enabled. That's another thing. You want to have the output enabled to only be enabled while the actual data needs to be out. You cannot have the output enabled getting the data out of the chip, the device you want, while you're updating the address, so there would be a conflict. So there's these little intricacies of, okay, when you want to extend the bus, you need to make sure that all these things happen. So this is an example here where the ready lines is being pulled low. Then you have the chip select being enabled, and then you need to be able to supply the data at the right time, at the right clock moment, for it to be fetched be sampled by the CPU at the right time. So that was a challenge, and it was not a small challenge per se. It was like I struggled many weeks on this to make it work properly, and was like, and disclaimer, I'm going to say something. It's not a critique. It is a critique. Bill, I'm sorry. The data sheet is very simple when it comes to timing information. It's one timing diagram. And if I would have been able to tell Bill 30 years ago, okay, dude, you need to make this a little bit more detailed. You need to put more information about how the ready line system works and when and how, because this one timing diagram on the spec sheet is so, there's so much stuff in there. it's very difficult to really grasp the idea behind this. Anyway, sorry, I don't mean to hurt anybody's feeling. As a developer, if I had a complaint to do to the creator of this part in terms of documentation was, okay, that timing diagram needs to be better, or there's need to be more, like a read cycle, a write cycle, a ready cycle with details, how it behaves, and where's the window where the data can be valid or not. I mean, this information is there, but I overlooked. You see, I'm asking for a better documentation. I don't read the damn thing. So it's my fault. Anyway, so that brings me to the challenge number 3, and that's basically my fault again. So you see, hubris. So the deal is that early on, I had one part, 3 FPGAs. The bus was driving all those FPGAs, plus the memory, plus the flash. So there was a lot of loadings. And what the loading does is stretching your rise and fall time. And if you see on the right here, you see that when the signals, and I'm exaggerating the graphics a little bit here, but you see the point is that if you have a signal coming and it's really fast going up and down, then you get to be recognized as one at the right time. If for some reason you have a lot of loadings on your bus, then the rise time take more time because there's more capacitance on the line. Then everything starts to be a little bit slower and slower and slower. So the time that the gate sees your values to 1 is been skewed, and it's been recognized before, and then it's recognized after. And sometimes it's a good thing, and sometimes it's a bad thing. Because if this thing stretch like a lot, then you can have issues. Like for the clock cycle, that was an issue. And it was also an issue with the ready line, because the ready line was an open collector input, and it had a resistor, pull-up resistor, and that pull-up resistor with the line loading was really like a long rise time and fall time. That's the nature of those, unless you really put like a really small value for the resistor to make it like drive a lot. Those rise time and fall time are long. So by loading the ready line, I was really stretching it to the point where I could literally offset the whole thing by 1/2 clock cycle. It was terrible. And that was a big deal. And that actually made me change one revision of board to another during my nightmarish time in 2019. It was really a doozy. And so the solution to that was ultimately to get all those ready lines coming from different devices to be sent to one device, and all that device would OR them together in a normal fashion, and then only one device would drive the ready line. So then not loading the whole thing. Because if I was going to put an expansion, that things would have gone out the window, and that would have not worked. The system would have not worked. It happens because I designed this Piggy, this data card for audio sound, and that didn't work. I did the mistake of using one clock signal for everything, and I had the same problem with the clock, which made me realize that the 65816 is very sensible to where and when the data needs to be valid. Because if the clock was going to be skewed because there was more or less load, then the moment the data would appear or disappear would be very critical. So that's one finicky part about the 65816 is the fact that it's very specific about when and how. So if the clock is skewed and the ready line is too long, then everything goes down the drain. And that's what I've experienced. I was going to say something about something, but I guess I'll move on. So we're 30 minutes in, and this is what the experience of the CPU was about. These were mainly my biggest issues, and like I said, half of those problems were created by me. Probably 90% of the problem were created by me by loading the bus, which means that I should have had more buffers to allow to the CPU to not drive so much, to have like one clock driver for every device, have one ready line drivers. But these are the parts of what the whole design is about, the debugging part. Overall, as far as I'm concerned, in terms of everything else, from the moment it worked. then all the grievances I could have, well, I don't have that much grievances after that. I think software people have grievances usually about the different, you know, different new registers when you're extended mode. But I don't want to get into this. This is another chapter, and I wouldn't want to go there because I think it's irrelevant to the discussion. So that leads us inexorably to what's going on next. Um, in June, I put out a video saying that I was going to stop. Well, I was going to stop. Yes. Um, uh, Time was tough because I felt I put a lot of pressure on myself, and some people complaining. I was tired of the complaining. It's like, listen, if you don't like it, just, might as well go get something else. There's plenty of solution. Design your own. Because I'm a pleaser. I want to please people, and when people are not happy, that puts more pressure. And those machines are taking a long time to build. I mean, the surface mount machine was taking an hour just to create one, to put all the parts on. I mean, the surface mount machine was about 15 minutes, but then everything else I needed to put on, because it was not big enough to put everything. I had to put everything else, take an hour. From that moment, it took another 5 hours to actually getting everything done and finished. So that took a toll on me, and I was like, okay, needs to stop. But in my mind, I was not really stopping. I was just really putting an end to people coming to me and say, oh, I want this, I want this, I want this. So in a way, I wanted to keep going, and I wanted to give me some time to finish the development of VK2, which I'm almost done with. And then my life, my life changed. Like a lot of people's life changed, job wise and everything. Although that was a choice for me to leave where I was in September. So, well, yeah, left in September. So I think I decided to give myself a second chance with that project. I think the Foenix will rise from its ashes, and I want to bring something new, and I want to present it to you today, because the FMX is great, but the FMX is a very fancy machine. It's very complicated, takes a lot of time, and if I want to make this a success, I wanted to grow my own audience, and that's one thing I wanted to do, which means that I wanted to create. I started doing some streaming. I need to do more. I need to have a little bit more time. And I want to find a way to get this in people's hand, because that's part of the deal. Having software, the idea at the beginning was, let's get a unit out, let's get people to develop, but life happens. So maybe half of the people got a unit are actually doing stuff on it, and sometimes they're just tinkering with it. They don't know doing anything really like meaningful for people to use, and it's perfectly fine, because it's their prerogative to decide what to do. Because I see the need of having software in order to put it together for a platform to be successful. Unfortunately, I don't have David's audience, so I just figure, okay, let's inspire people to do more. And so I started to do streaming, creating games that we know, and to use them as use cases to implement a new game, and to get the code to be free and for people to download, to use as an example, to get people kickstarted. And that's the idea. That's what I want to do. But for that, I need a machine that is more accessible and cheaper, because apparently price is a big deal. Although you would think that in this world of hobbyism, price is no problem. But some people manage to get in people's mind that pricing is important. People are paying $300 for a keyboard, but they're not willing paying $200 for a computer, which doesn't make any sense to me. But hey, that's the nature of the beast. But anyway, so I'm ready to announce today that I'm going to release probably in December, the Foenix U, which is something I've been talking about for a long time, which is the user version. The user version is a cheaper version, a smaller version, which at this point will include pretty much what the other one had, albeit a couple of things that would not be there. So let me run down the differences. Same CPU, same speed, half of the memory. I think, already 2 megabytes is a lot for both, which is a total of 4 megabytes on the system, mind you. Fat Vicky, I'm calling her, making a link with obviously with the Amiga, but it's basically Vicky heating Gabe and having one single FPGA on the board. Something I didn't want to do, but the U version is a version of the FMX without the bells and whistles, all the restriction that I gave myself from the beginning. It's really like, okay, let's get this thing manufactured by third party. I don't have to do it myself. It's really, I take it from one hand, I'm going to give it to the other, just test it, make sure it works, and get the price down. The PL3 will remain. These are still very much available. I get parts reels, so I know reels exist. Till they're not available anymore, I'll keep the real part. I think it's important to have a genuine sound. I will be transferring, if possible, the Open2 APM and PSG into the FPGA. Somebody did the design. I need to tag the person to get the permission to do this. Gideon SID is still there. The SD card is there. The ID is still there, as you can see on the picture. And I put a star there, like an asterisk, to say that there's a connection. This connection here is to put a dollar card with the LPC to put back the Super IO to get access to the media again, the serial ports, and the floppy if one would care about having these things. Obviously, the joystick's going down from 4 to 2. I think 2 is enough. The connector, the expansion connector is compatible with both. So if you design something for the FMX, it will work with the other. The background debug mode is still there. Something I wanted to remove, but I figured that it's the best way to open up the ability to develop with it would be to keep it. The product will be sold without enclosure. I might offer a model with an enclosure. The size of the board is literally half of the other one, almost, in terms of surface. So now anybody can 3D print their own enclosure. It's small enough for any 3D printer out there. I mean, the decent one, of course. We're talking about a price of $199. Obviously, if the module, the overall quantity is there, then, you know, I'm thinking about maybe doing a Kickstarter. The price could go down. And basically, from the moment the VK2 design is finished, almost finished now, the only work I have to do is to integrate both FPG together, and I'm done. So the development time between the FMX to UU is very short. So I can probably, unless there's any supply problems, be able to start selling in December 2020. And the deal is that by October, I should announce it officially, and you should be able to do pre-sale in November. I start pre-selling in November. So by the time I know it's working, I start the pre-sale to make sure that I'm not selling a vaporware, but this is certainly not vaporware. I'm literally full-time on this now, so I'll be accessible. I'll create more content for it. That is my goal, to really create like an ecosystem for it. I want to literally develop expansion boards for it, Ethernet connectivity, which should make some happy. Please don't put Linux on this, please. There's a whole, story there. I don't want to go there. Create a board to put real SID chip. I still believe it's a soundbox. It needs to remain one. I need more developer, people doing conversion maybe from Super NES or creating new games. That's what I'm targeting. I want more content for it. It's a great machine. We need to create a community. I want to create a bigger community for that platform, and I will work very hard to get there. Super IO data cards. I'm also thinking about to help those CPU people that want just to design their own CPU, to use their own CPU, to create a VQ2 modules to get people access to this VK module, this graphic engine for people to use in their own projects. This is something I want to do. The trick with this is really to ultimately find a way to having one platform and be able to deal with multiple different processor, which means that I would have to test those processor. And so that will take a little bit of time, but it would be like a single modules with a connector and everything, a piggyback that you could put on your breadboard, that you could interface. Obviously, if you're dealing with a 6502, then I would have to put like some kind of mapped register, bank register that you could change to address all the register you want. Make it like a low overhead to address all the memory. I want to do a full game development on the platform. I started doing my own version of Jumpman. My first use case of my streaming is Jumpman, the original Jumpman, but I don't want to do the whole game, just want to do a couple of levels just to inspire. Again, I really want to inspire people. I would like to do also a 68,000 version because it's dear to me, which would be called the 2560. And that version would be with the keyboard, but it's for longer towards the end of the year. It's going to be on the back. I don't want the pressure. I don't want to make the same mistake again. So at this point, I'm drawing to an end. This presentation is drawing to an end. I'm almost at 45 minutes. This is my goal for the upcoming months. Really spend most of my time on this, get the word out, get more people in. I think $200 is a fair price. I think it's a great platform, a lot of potential. Don't underestimate the value of challenging yourself to, target a new system. That's what I'm selling. I'm selling the idea of going back to the time where you're getting into a new machine. You need to discover it. You need to poke at it, discover its texture and essence, and try to get the best out of it. And I know some people are waiting for their units right now to actually do that. Demos, if people would get into doing demos, I think it's a great machine to do demos. So a lot of potential. And I'm not denigrating anybody but else. I think the market right now in terms of new retro is awesome. I mean, the Mega 65 is great. It has its own niche. The Commander has its own niche. I mean, it has a lot of people going in there. It's great. There's the Neon 816. It's a different angle. It's great. All these projects are great for the community, and I think it's a great time to do retro. But for me, I'm coming from a place of I want to rediscover this passion, and I'm so looking forward to go back and to actually do my own games and to rediscover this pleasure. And I want to bring people with me on that journey, and I hope you can join me. And I'm really trying my best to get this out there, and I need your help. Hopefully you can be there. Thank you very much for your time. Again, Jeffrey, thank you very much to be there, to invite me into this event. Hopefully next year I can be there locally and meet you all. And if you have any questions, please ask the Q&A, and or you can go on the website. My email address is Steph, S-T-E-F, like Frank, at C256Foenix.com. There's a Discord channel. You can find me on Twitter. Very easy to find me on Twitter. I have a page on Facebook as well. So Facebook and Twitter, pretty much where you're going to find me. Yeah, that's it. So thank you very much. Have a wonderful day. Have a wonderful show. Jeffrey, thank you again. VCF people, thank you again. Everybody, thank you again. And I will talk to you soon. All right. Cheers.